সেশনে যেহেতু আমরা বেসিক লিমিট আর ডেরিভেটিভ নিয়ে কথা বলবো, সো ফার্স্ট আমরা জানতে চাইবো যে হোয়াট ইজ লিমিট, লিমিটে আমাদের মোটিভটা কি। ওকে, সো লিমিটিং কোশ্চেনের আমাদের বেসিক মোটিভ যেটা থাকবে সেটা হচ্ছে যে আমাদের লিমিটিং কোশ্চেন বা আমরা যখনই কোনো রিলেশন ইউজ করছি টু ডাইমেনশনাল ক্যালকুলাসে, over there we know that there is a dependent variable and there is an independent variable, right? এবার ইন্ডিপেন্ডেন্ট ভেরিয়েবল ইন্ডিপেন্ডেন্টলি মুভ করে, তার উপরে ডিপেন্ড করে ডিপেন্ডেন্ট ভেরিয়েবল ভ্যালু জেনারেট করে, রাইট? এবার ইন্ডিপেন্ডেন্ট ভেরিয়েবল কিভাবে ভ্যারি করতে পারে অ্যালং দি নাম্বার লাইন, যে কোনো রকম জায়গাতে থাকতে পারে, ডিপেন্ডিং অন হোয়াট টাইপ অফ ফাংশন ইউ আর অ্যাপ্লাইং অন দি ইন্ডিপেন্ডেন্ট ভেরিয়েবল। কিছু রেস্ট্রিকশন আসতে পারে, যদি রেস্ট্রিকশন কিছু না থাকে ইট ক্যান বি এনিওয়্যার অন দি নাম্বার লাইন। এবার নাম্বার লাইনে যখন ইন্ডিপেন্ডেন্ট ভেরিয়েবল মুভ করছে, ইট ক্যান অ্যাপ্রোচ সার্টেন ভ্যালু অর ডাইরেকশন। এবার নাম্বার লাইনের রেসপেক্টে যদি আমরা ডাইরেকশন ভাবি, ডাইরেকশন তো মাত্র দুটো। নাম্বার লাইনের একটা রাইট সাইড ডাইরেকশন which is gradually moving towards infinite, positive infinite, or otherwise আর একটা ডাইরেকশন হচ্ছে লেফট সাইড ডাইরেকশন। এই লেফট সাইড ডাইরেকশনটা গ্র্যাজুয়ালি মুভস টুয়ার্ডস দি ডাইরেকশন অফ মাইনাস ইনফাইনাইট। এই দুটো ডাইরেকশন ছাড়া হোয়াট এভার উই হ্যাভ অন দি নাম্বার লাইন, দিস আর অল ইন্ডিভিজুয়াল ভ্যালুস। And let us firstly have a look how independent variable can show its approaching nature on the number line. So if we believe that the on the number line a is a fixed value, so x can approach a fixed value either from the right side of a or from the left side of it. If x is decreasing and gradually becoming closer and closer to a, we will consider x is approaching a from right. Now, when I'm saying x is approaching a from right, at what difference x is situated from a, it cannot be represented in terms of a margin. It should be sufficiently close, which is a bit of hypothetical description. Okay, because when I'm saying sufficiently close, that means it is closer than the interval that you can write. You write any interval of margin at which distance x is situated from a, the actual distance will be something lesser. So that is why instead of writing something, we denote this particular phenomenon as x approaching to, this arrow should be read out as approaching to, and then a plus. Okay, so a plus means x is more than a and coming towards it. Or otherwise the fixed value a can be approached by x from the left hand side. And how it can be approached? X can approach a from left will be denoted by x approaching to a minus. Means x is a bit smaller than a, but how much smaller than a? It cannot be represented in terms of any margin. So again, that's sufficiently close. That means on the path of movement, x was increasing and gradually moving towards a or becoming closer and closer to a. This phenomenon can be described as x approaching to a minus. And as I told you earlier, there are two directions: the right side direction moving towards infinite, the left side direction gradually moving towards minus infinite. Now, due to this approaching natures of x, how the dependent variable reacts or what type of value it generates, this study is called study of limit. Is that clear? So under limit, what we are trying to have, that due to this approaching nature, so we can conclude the limiting behavior of y is equals to f of x. If I believe y, the dependent variable, is following some relation f on x, due to approaching nature of x, if and only if limiting behavior is consistent. Now, what is limiting behavior? Okay, as x is showing this approaching nature, how the y reacts or what kind of value it generates. Okay, so this study is limit. Now, in terms of behavior, what can be there? Say y is x square. So as x is approaching a, y should be approaching a square, right? So if there is a fixed relation f and x is approaching a, in general, we can believe y is supposed to approach f of a. Now, what are the problem in this conclusion making? Why we cannot stand with that every time? Like we can have such behaviors. So we can have a reading of the curve y is equals to 1 by x. Now you can identify if we are into y is equals to 1 by x relation and x is approaching to infinite, gradually the ordinates we are getting over here or the values of y gradually approaching towards 0. In particular, if I need to write, then y basically approaching 0 plus here, right? Gradually y is becoming more and more less positive, more close to 0, but from the positive side. So we can say that as x approaching to infinite, y is approaching to 0 plus. As such, saying y is equals to 0 will not make any difference. But when x is approaching to 0, from the right side of 0, gradually the values of y approaching infinite, it's going up and up. Immediately to the left of the y-axis, when we are getting x is approaching 0 from left, we are getting the ordinates of the point gradually moving downward. So y is approaching to minus infinite. Whereas as x approaching to minus infinite, y is approaching to 0. And as the diagram suggests, in particular, you can say y is approaching to 0 from lesser side or y approaching to 0 minus. Clear? So if I try to know about behavior of y when x is approaching 0, but it has not been said from what side, then do we have a consistent behavior in y? Can everyone follow my question? So I'm reading this curve, the combination of the two.
Right.
Yes, beta. Can you repeat once?
Sir, so it can be either infinite or minus infinite, right?
Yes.
Why?
So is there a consistency in the behavior?
No, sir.
No.
No.
Because depending on whether x is approaching 0 from right or from left, we are going to have behavior of y abruptly opposite. Okay. On one side, it was approaching infinite with positive sign. On the other side, it was approaching infinite with negative sign. So it's either upward, vertical upward direction or vertically downward direction. So this is not consistent behavior. But if I believe the limiting behavior of y when x is approaching to 3, somewhere like this, if I mark a point, say 3. So as x is approaching to 3, doesn't matter from left or maybe from right, on either occasion we will have the value of y approaching to 1 by 3, right?
Yes.
So over there the behavior of y is consistent. So if our x is moving to 3 from left or moving to 3 from right, the curve suggests values of y is consistently approaching 1 by 3. So when the behavior of y is consistent, then we do have a limiting value. And if the behavior is not consistent, then we do not have a limiting value. Is it okay? Like the first example of limit that's been provided to you in terms of the basic trigonometry value table. Can you all recall? প্রথম যে trigonometric value টেবিলটা পড়েছিলেন সবার মনে আছে তো?
হ্যাঁ স্যার।
Yes,
So
sir.
what were the angles that we were addressing in that basic trigonometric value table?
30 degree, 60 degree, 90 degree,
Even before that, what was the
45.
next angle in that table?
45
Zero.
degree.
0,
Yes, sir.
right? If I say in radian system, so 0, then pi by 6, then pi by 4, then pi by 3, and then right angle. That is pi by 2. But do you actually believe that there can be a right triangle with angle between base and hypotenuse 0 or pi by 2 in exact?
No, sir.
It's not feasible. But even if you recall that in the column of angle 0, there were 4 trigonometric operations which were defined with values, and there were 2 which was not defined with values, right? 2 of the operations, like for 0 angle, it is cosec and cot. These 2 operations is not defined with value. Similarly, if you can recall the column of the angle pi by 2 or right angle, even over there, 4 of the operations were defined with values, but 2 of the operations, that is sec and tan, they were not defined with values. So what was the difference? Why 4 of them were defined with such values, which is not feasible for any right triangle to appear between base and hypotenuse of the triangle? Whereas 4 of the options or 4 of the operations are getting value, and 2 of the operations are being not defined with value. So it was again the consistent behavior of the operations. Like when the angle is very, very small and approaching towards 0, sine was consistent in both variation, very small but positive angle, or very small but negative angle. Under both variation, sine was approaching the same value 0. So sine awarded with the limiting value 0. Is that okay?
Yes, sir.
Am I clear?
Yes, sir.
Similarly, if you think of cos, under both such variation, the operation cosine under the angle 0 was approaching to 1. Doesn't matter whether the angle was approaching to 0 from positive side or from negative side. Under both variation, cos has shown the tendency, consistent tendency of approaching 1. That is why cos is defined with the boundary value when the angle is exactly 0 and you are not getting any feasible triangle, still the value been awarded. But if you look into the behavior of cosec or cot, they were not showing any fixed tendency towards the angle 0. Similarly, now as we are done with the basic trigonometric curve, and you can follow from there that sec and tan, they do not show any consistent behavior about the odd multiples of pi by 2. So that is why they are not defined with such angles even on the limiting sets. But those who were consistent on their behavior, as a result of their consistency, they have been awarded with values with the terminal or limiting angle, even though that was not even valid to appear between base and hypotenuse of a right triangle. So that was the first idea where we encounter with the ideas of limit. But as we do not know the ideas of limit, we do not speak about that. We simply mug up the table. Okay. So now you can justify why that was happening after the idea of the trigonometric graph and the idea of limit. Now, if x is something which is approaching the right side of the number line, that is approaching to infinite, then x to the power lambda will approach infinite for any positive values of lambda. Similarly, x to the power delta will approach 0 plus for any negative real values of delta. So when your variable is infinite approaching with any positive power, it will still remain infinite approaching. But if your infinite approaching variable appearing with a negative power, then definitely the appearance is approaching to 0 from positive side. Is it conclusive for all?
Yes.
Yes, sir.
Yes, sir.
Similarly, when x is itself approaching to 0, x to the power lambda is approaching to 0 for lambda being positive. But the approaching nature of x to the power delta for delta being negative real number will be dependent on how x is approaching to 0. Whether it has been approaching to 0 from right or from left, if you do have that specific information, then only you can conclude about x to the power delta behavior. Can you tell me if x is an independent variable approaching to 0, what will be the value of x to the power 0? Can you all follow my question?
Sir, it will always be 1.
It will always be 1 because the power was not showing any tendency, right?
Yes.
Yes, sir.
Like for the second variation, we have said when the negative power come into the scenario, when x is approaching 0 from positive side, we can identify x to the power delta, where delta is negative real number, will still be approaching infinite. But if x is a negative number but sufficiently close to 0, that is x is approaching 0 minus, then we get x to the power delta approaching minus infinite. Is it okay to all?
Yes.
Yes, sir.
Now, to identify how limit acts, we will firstly go through a specific idea, that is ratio of polynomials. Okay? So let us consider two polynomials, and why we are getting into that, that so far what we have discussed about limit, it might have given you the idea that basically limiting behavior of y when x is showing any particular tendency or approaching nature, it is basically can be identified by substituting that approaching value of x in the relation with y. And that will definitely work provided the value or the direction x is approaching, that is substitutable. Now over here, if x is approaching towards a value, then it is substitutable. But if x is approaching towards a direction, that is the direction of infinite or minus infinite, then it is not substitutable on paper. Say x is approaching to infinite. What does that mean? X is a very large number and gradually it is getting larger and larger, right? So in that case, how strongly x is approaching infinite, it will be dependent upon the power of x. Do you all agree?
Yes, sir.
Yes, sir.
Okay. The higher power x will have, the more strong way it will approach infinite. And the less power x will have, it will still be approaching infinite, but the nature of approaching will be a bit weaker in that case. Is it clear? So when x is approaching infinite, this is something we cannot substitute on paper. Like if x is approaching infinite, infinite is not a number to substitute. So it is basically a sense that we need to deal with. And we can identify if x is approaching infinite with higher power, it will be generating more strong nature in that approaching nature towards infinite. With lesser powers, the behavior will be respectively weaker. Similarly, when your variable x is approaching towards 0, so how will be the behavior when x has higher powers? Approach towards 0 will be high or stronger or weaker?
It's stronger.
Stronger. Because if there is a small number, if you multiply the small number with itself, it will become smaller. This is common phenomenon for all the numbers which are numerically less than 1. If you multiply them with themselves, they will be numerically smaller quantity, right?
Yes. Yes.
So something very close to zero, if I increase its power, means if I keep on multiplying itself with the number itself, then it will be becoming more and more small, and gradually it will be approaching zero on a stronger note than earlier. Whereas if we have the lesser powers for the variable, it will still be approaching zero if the power is still positive, but the nature of approach will be weak. So when your variable is approaching towards zero or infinite, with higher power, the nature is stronger. With lesser power, the nature of approach is weaker. Is that okay to all?
Yes.
Yes.
Yes, sir.
Yes, sir.
So say we are dealing with two polynomial. One is P of x and the other one is Q of x. P of x is an n degree polynomial with leading coefficient an, and say we are believing that the least degree of x in polynomial px is k degree term with coefficient ak. Okay, k is a whole number, means you may have the last term as the constant term, or might be possible k is a natural value. So both the opportunities been kept alive by saying k is a whole number, but definitely degree is natural number, and ak into an is non-zero, means neither the leading coefficient nor the coefficient of least degree term is zero, because if at least one of them is zero, then the product would have been zero. Similarly, in polynomial q of x, it is a odd degree polynomial with leading coefficient br, and the least degree term is the mth degree term with coefficient bm. Again, m is a whole number, the degree r is a natural number, and neither the leading coefficient nor the coefficient of least degree term is zero, because their product already denoted as non-zero. Clear?
Yes,
The
sir.
description of the polynomial.
Yes, sir.
Yes,
Now the
sir.
first variation that we are willing to read, that what will be the limiting behavior of px by qx when x is approaching to infinite. Are you getting this point? If x,
Yes.
your independent variable, approaches infinite, তাহলে এই পলিনোমিয়াল দুটোর রেশিও সেটা কিভাবে রিঅ্যাক্ট করবে বা লিমিটিং বিহেভিয়ার কি হবে। সো বারবার যাতে আমাদের এই পুরো লিমিটটা না লিখতে হয়, we have given it a name L1. So over here L1 is not a value but basically denotion of the limit. Is that okay to all? Now
Yes.
we have already identified that when x approaching to infinite, p of x কাকে approach করবে? If x is approaching to infinite,
Sir, infinity.
infinite,
Infinite.
and q of x কাকে approach করবে?
Infinite.
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 Sir, infinite.
Everyone convinced about that? That when
Yes, sir.
variable x is approaching infinite, both these polynomials will approach infinite.
Yes, sir.
So why we are not writing a limiting value? Can I write the limiting value 1 as both numerator and denominator is approaching to infinite? Can I cancel infinite and
sir.
infinite to
No,
write
sir.
1?
No, sir.
No,
No,
sir.
sir.
Cannot. Because we know that infinite is not a value, it's just a direction, and both my numerator and denominator is approaching towards same direction, and the ratio will be dependent upon their individual strength. Okay, so in limit there are certain forms where even after knowing the part is approaching nature, we may not stand conclusive about the overall limiting nature. Such formats are called indeterminate forms. Okay, As such, there are 7 indeterminate forms. So indeterminate forms means basically we can consider of, say, for example, you can consider of, do you all follow cricket?
Yes, sir.
No,
Basic
sir.
rules of cricket,
Yes, sir.
সবাই
Yes.
জানি তো? Okay?
Yes.
নর্মাল মানে ক্রিকেটে গোল হয় না, ওকে, বা অফসাইড হয় না। অফসাইড হয় মানে ফুটবলে যেভাবে হয় সেইভাবে হয় না, এইটুকু জানলেই হবে। ওকে, সো সে ইন ক্রিকেট উই ডু হ্যাভ 2 very strong batsmen. Okay, can you give me 2 names, or give me 1 name for a strong batsman? Recently Surya Kumar Yadav has scored a century for India.
Yes,
Can
sir.
I
Yes.
take his example?
Yes, sir.
So
Yes.
say Surya Kumar Yadav, he is a very strong batsman and very consistent of his nature. We are taking a hypothetical condition that whenever Surya Kumar faces a ball, he hit it for a 6. Okay. Now, can you give me an example of a strong bowler from the international cricket? Anyone? You cricket follow karo na?
Bhubaneswar Kumar.
Okay. So I have got a respectively older example. It's okay. Say
Yeah,
Bhubaneswar Kumar. Okay. So say he is so strong of his nature that whenever he bowls, he takes a wicket. Okay. And along with that, say I am another batsman and I am very consistent of my nature, but that is been considered under weakness. Whenever I play, I get out on the very first ball. Okay, irrespective of the bowler, whoever bowls, okay, I have always got out on the very first ball. I have never seen what is called second ball. So all my scores are golden duck. Okay, and say there is a very weak bowler. Okay, say person X. Let's not take anybody's name. Say person X is so weak of his nature that whenever he bowls, he get hit for a 6. So now we do have 4 persons. They might not be equally good on the basis of the game, but they are very strong of their individual nature. Surya Kumar, whenever faces a ball, hit it for a 6. Bhubaneswar Kumar, whenever bowls, takes a wicket. I am a weak batsman. Whenever I play, I get out on the very first ball. And Mr. X, whenever he bowls, he get hit for a 6. Now, can you tell me the result if Mr. X bowls to Surya Kumar?
6.
6.
If
6.
Bhubaneswar Kumar bowls me,
Wicket.
Out.
Wicket.
okay. If Mr. X bowls me,
Can't be determined.
Yes.
No ball.
so not no ball. Mr. X has every time bowled a legal ball and got hit for a 6. And he is bowling to me. Every time I faced a ball, I have got out on the very first ball. Now, can you predict the result? If Mr. X bowls me,
No, sir.
Then considered to be
No,
the
sir.
even after
indeterminate
being
form, right?
weak, we are very consistent on our own nature. So now we need to know আমাদের দুজনের মধ্যে কে বেশি উইক, আমার আউট হওয়ার টেন্ডেন্সি বেশি স্ট্রঙ্গার নাকি মিস্টার এক্স এর বিং হিট ফর আ 6 দ্যাট নেচার ইজ স্ট্রঙ্গার। যদি কোনো একটা বেশি স্ট্রং হয়ে যায়, যদি কোনো একটা পার্ট স্ট্রঙ্গার হয়ে যায়, তাহলে সে নিজের ফেভারিট রেজাল্ট নিয়ে নেবে। অর আদারওয়াইজ যদি দুটো স্ট্রেংথ কম্পারেবল হয়, so it might be a result which is neither 6 nor a wicket. হতে পারে তো, maybe a dot
Yes,
ball,
sir.
maybe 1 run, maybe 2 run, anything like that. Is that okay?
Sir, it can
Similarly,
also
when
be wicket.
Bhubaneswar Kumar bowls to Surya Kumar, So what will be the result? Can you predict that?
No,
No,
sir.
sir.
No, sir.
Because both of them are very strong of their nature, but try to take the result on opposite way. Is that okay? So when two strong natures comes together to take the result in same way, then the result is very strongly predictable. Like Bhuvaneshwar Kumar bowls to me, so you have all predicted a wicket, which has to be true. If Mr. X bowls to Surya Kumar, all of you have predicted 6, it has to be true. So similarly, if we think of a ratio in mathematics, where the numerator is very large, what is the general expectation from that ratio? A ratio value whose numerator is very, very large. What should be the general expectation from the ratio?
Infinity.
It tends to
To be
infinity.
large. Let's not say about finite or infinite, but the ratio value is supposed to be large.
Yes.
Yes.
But if the
Yes.
numerator is very small numeric value, then as per general
Very-
expectation,
It will be a bit more
we
small.
will expect the ratio to be a small value. And
Yes.
if the denominator is a large value,
So then it's a small value.
Small
Very
value.
small
general
value.
expectation that the ratio will be small. And if the denominator is a very small numeric value,
A
Then a
very
big-
general
large.
expectation ratio value will be large. Now say a very large numerator accompanied by a very small denominator. Will we have any confusion about the nature of the ratio?
Yes, sir. Confusion.
Confusion থাকবে? Numerator very large, denominator very small.
No, sir.
No, no.
Sir.
Confusion.
Sir.
No,
থাকবে।
No,
Because
sir.
both are strong of their own nature. And are they
Sir.
trying to take the result in same way or opposite way?
same way.
Same way.
Same way.
So general expectation is not needed. We can conclude that the ratio value will be very, very large. Right?
Yes.
Similarly, a small numerator accompanied by a very large denominator. How will be the ratio value?
Very small.
Very small.
Very small. So again, very strong parts coming together and try to take the result in same way. But if I do have a very small numerator accompanied by a very small denominator, do you stand conclusive?
No, sir.
No,
Because they are
No,
strong
sir.
of their nature, but now they are trying to take the result on opposite way. Numerator will be trying to make the ratio small. The denominator will try to make the ratio value big. And hence, it will be dependent upon their individual strength. Similarly, if a very large numerator accompanied by a very large denominator, so tendency of numerator will be to make the ratio value large, whereas the denominator will be trying to transform the ratio value into something small. So two strong parts working in opposite way. So in that case, we will not stand conclusive. And similar problem has arrived with limit x approaching to infinite p of x by q of x, because now we do have a limiting ratio where the numerator and denominator are very large. So as we have decided, now we need to check their strength. And as we decided earlier, that the infinite approaching nature or infinite approaching strength will be judged by the highest degree. So we will compare the degree of the two polynomial, numerator having degree n, denominator having degree r. So we are considering case 1. If degree of numerator is higher than degree of denominator, so who is stronger in infinite approaching nature?
P
Is
of
it
x.
p of x or q of x?
P of
P
X.
of x.
Very
P of
good. Can we all follow that? So if numerator is stronger, it will take the result on its favor. So definitely the ratio value supposed to be something very large. To stand conclusive, we can go by this form that we will divide numerator and denominator with numerically greatest term, that is x to the power n. And why we are doing so? Because even after knowing this trend, to establish the value, we cannot substitute infinite for x. Whereas we know that if x is approaching to infinite, then reciprocal of x is approaching to 0 from positive side, and that is our substitutable value. So to transform this into positive powers for 1 by x, we will divide all the terms of numerator and denominator with the highest degree term, that is x to the power n. And due to that, we do have formations like this. So 1 by x with natural powers, these are all approaching to 0. So whatever been written in blue after the division, these are all approaching to 0. Right? Confusion on that?
No.
So that means after this division, we can ensure that numerator is approaching to an now, whereas denominator approaching to 0. Right?
Yes,
Do you
sir.
all agree?
Yes, sir.
Okay. Now, denominator is approaching to 0, but still, what is the numerically greatest term from denominator? Can you identify that? Because when 1 by x we are treating, it is approaching to 0, and the less power it will have, the more numerically great it will be.
Yes, sir.
N
BM.
minus n.
Yes, sir. N minus.
তাহলে এই টার্মটা numerically greatest হওয়া উচিত, right? N minus r is the least power that 1 minus x have. Can you all follow that?
Sir, I could not follow. Would you please repeat?
ধরে নাও p is a variable which is approaching to 0 plus. তাহলে p square, p cube আর p to the power 4, among these three, which one is numerically greatest?
Numerically greatest p square.
P square. That means the term which is weakest on 0 approaching nature is numerically greatest.
Yeah.
Power যত বেশি হবে, 0 approaching
কম।
nature তত strong হবে. Power
হ্যাঁ।
যত কম হবে, 0 approaching nature তত weak হবে. আর 0 approaching nature weak হওয়া মানে numerically greater হওয়া.
Yeah.
Is that okay?
Yes,
Now,
sir.
how is 1 by x, which is written in blue?
Tending to 0. Close
Tending
to 0 plus.
or these are positive numbers, very close to 0.
Yeah.
So if it has lesser power, then it is numerically great. If it
Yeah.
has higher power, then it is smaller value or more strong to become closer to 0. So numerator having a term free from 1 by x, so it is approaching an, non-zero value an, but denominator approaching to 0, right? Even though the denominator is approaching to 0, you can identify 1 by x having the least power n minus r. The next term has having greater power for 1 by x, that's n plus 1 minus r. And so on. As we proceed towards the end of this line, we are getting higher and higher values for 1 by x. Right? Acceptable?
Yes, sir.
So তাহলে যেখানে least power, this is numerically great. So that means numerator approaching an and denominator will approach 0 with same sign as BR. Can you confirm so? As this term is going to be numerically greatest, So though the denominator is approaching to 0, it will approach 0 with the sign of BR. Can you all follow that?
Yes, sir.
Yes.
So that means from this portion, this is our conclusion we have already gone through. So L1 must approach infinite with the sign of AN by BR from this section. Can we follow? If AN by BR is positive, then L1 should approach infinite. If AN and BR are of opposite sign, then the ratio will be negative and L1 should approach infinite with negative sign. Because
Sir, could you please explain again why?
Zero quantity, whereas the denominator is approaching 0 with the sign of BR.
Sir,
Confusion আছে বলো?
sir, could you please explain why BR 1 by x to the power n minus r is the it is approaching to 0 from where it is determined, why it is determined by BR?
Okay. Tell me, what is the least power 1 by x have from denominator?
Least power is n minus m.
N minus?
N minus m.
Which one is great? R or M?
R. Achha, n minus
is
r.
great, right? R
Yeah.
is greater than M.
Yeah.
So R is greater than M. Any confusion in that?
No.
So what will be relation between minus R and minus M?
Less than.
What about N minus R and
Less
N
than.
minus M?
Less than.
So which power is less? N minus R or N minus
N
M?
minus r. N minus r.
Is it clear now?
No, sir. The a 1 by x to the power n minus r, it is approaching 0 from which side? How is it determined by the coefficient?
Okay, tell me, P is approaching to 0,
Yes.
or more particularly say 0 plus.
That is from positive side.
Then P cube কাকে
Close
approach
to
করবে?
0 plus.
0 plus. আমি তাকে একটা a দিয়ে মাল্টিপ্লাই করলাম,
হ্যাঁ।
তাহলে
0
approaching
plus.
method সেম থাকবে?
হ্যাঁ।
ধরে নাও এর ভ্যালু -2,
না তাহলে বাঁ দিক থেকে।
তাহলে এখন এটা 0 মাইনাস হয়ে যাবে।
হ্যাঁ।
কিন্তু যদি আমি 7p কিউব দেখি,
0 প্লাসই থাকবে।
আমি যদি মাইনাস পাই ইন্টু পি কিউব দেখি,
মাইনাস।
তো তাহলে কার উপরে ডিপেন্ড করছে?
b to the power r.
কিভাবে অ্যাপ্রোচ করবে সেটা কি পি কিউবের উপরে ডিপেন্ড করছে নাকি তার মাল্টিপ্লায়ারের উপর?
b to the power r এর উপর।
বিআর, ওকে,
হ্যাঁ।
নট বি টু দি
br
পাওয়ার,
b to the
বিআর
power,
এর
sorry.
উপর। সো এখন ব্যাপারটা ক্লিয়ার?
ওকে স্যার, তাহলে পুরো লিমিটটা কেন an বাই br এর উপর হচ্ছে? কেন কি an minus 1 br
নিউমারেটরে
minus
এন টা নন জিরো, আর ডিনোমিনেটর কি বিআর কে অ্যাপ্রোচ করছে নাকি ডিনোমিনেটর 0 কে অ্যাপ্রোচ করছে উইথ সাইন অফ বিআর?
no, second option. It is approaching 0 with the sign of br.
তার মানে আমরা একটা নন জিরো ফাইনাইট নাম্বারকে সামথিং ভেরি স্মল অ্যাপ্রোচিং টু 0 কোয়ান্টিটি দিয়ে ডিভাইড করছি। একটা ফাইনাইটলি লার্জ ভ্যালুকে যদি তুমি ইনফাইনাইটলি স্মল ভ্যালু দিয়ে ডিভাইড করো, what should be the numeric value of the ratio?
Large.
Very large, approaching to
Yeah.
infinite.
Yeah.
এবার তোমার dividend and divisor, if they carry same sign, then it is actually approaching infinite. And if
Okay.
your dividend and divisor carrying opposite sign, then the ratio value will be approaching minus infinite.
Okay, sir.
Now is it making sense?
Yes, sir.
Is it clear to all?
Yes.
সবাই ফলো করতে পেরেছি?
Yes, sir.
Yes.
Case 2, if r is more than n, so now the denominator is stronger in its infinite approaching nature, and the moment denominator wins, it will transform the limiting value into 0. So can you all follow?
Sir, can
Over
you
here,
please
as
scroll
we
up
have
a bit?
assumed r greater than n, so x to the power r was the highest degree term. So we have divided both numerator and denominator with that highest degree term, x to the power r দিয়ে divide করেছি. And as soon as it has been transformed into the form of 1 by x with natural power, now we can substitute 0. But due to that substitution, at this case, the numerator is approaching to 0 and denominator approaching something non-zero finite. This is sufficient to conclude the limiting nature. Is it okay? The third case is the most special one. That is when
স্যার
r
কেস
is,
1 এ কখনো মাইনাস ইনফিনিটি অ্যাপ্রোচ করতে পারবেন?
yes, what is said? L1 must approach infinite with the sign of an by br. So you know when it will be minus infinite approaching, what condition do we need for that?
n by b
অপোজিট সাইনস অফ এন এন্ড বি।
An and b are carrying opposite sign, right? So case 3 is the most special of them all, which says degree of numerator and denominator are same. So that means their infinite approaching strengths are same. So now x to the power r, which is equals to x to the power n, that is the highest degree term. And if we divide numerator denominator with that power of x, now after division, the numerator approaching an and denominator approaching br. And for the first time, we are supposed to have a non-zero finite limiting value for L1, which is an by br, that is the ratio of leading coefficients. Is it okay for all?
Yes.
Similarly, if we believe this second variation, that is x approaching to 0, p of x by q of x is equals to L2. Now, the nature of their strength will be judged by the numerically greatest term, that is the least degree term of x from numerator and denominator. So before proceeding ahead, just have a look. So now when x is approaching to 0, the numerically greatest term from px is this particular term, ak x to the power k. And from qx, the numerically greatest term will be bm x to the power m. Is it okay with all?
Yes, sir.
So when x is approaching to 0, so we will compare these two powers. So if k greater than m, then from here we will divide the whole numerator and denominator, each term from there with x to the power m, which is the least degree term combining both numerator and denominator, and hence this will be the scenario. Is it sufficient to conclude that the limiting value will be 0? Now combining numerator and denominator, if k is more than m, m is the least degree for x that we are getting combining numerator and denominator. So we are dividing numerator and denominator, all terms from there, with the least degree term, which is numerically greatest now. So in that division, we will have only one term free from x. Rest every term will still have x with some natural power. And as this time x is approaching towards 0, so if you substitute that value for x after this division, you can identify the numerator approaches 0, but the denominator approaches non-zero finite value Bm, which is sufficient to conclude the limiting value 0. Is it okay to all? Has
Yes.
everyone
Sir,
followed this?
please wait. Please wait,
Yes.
sir. Let us copy.
So how we are getting these values, is it clear to all?
Yes, sir.
Should I get to the case 2?
Yes.
So in case 2, we are assuming m is greater than k. So x to the power k is now least degree term. So if you divide both numerator and denominator with x to the power k like earlier, this will be the reduced form. But now numerator approaching non-zero finite value ak, and the denominator must approach 0 with the sign of bm, right?
Yes, sir.
Is it necessary? Or we need to know about m minus k also? Because this is the least degree from the denominator that we all can identify. So write down subcase A. If we believe that m minus k is some even natural number, say some 2p, then x to the power m minus k, that will always approach 0 from positive side, and hence the denominator will approach 0 with the sign of bm, right? Are you all getting?
Yes.
When the power of x is something even, তাহলে এই x to the power even, this portion is definitely positive, whereas numerically greatest term this part, so the multiplier bm will decide with what sign the denominator is approaching 0. And we know that in such occasions we will have L2 approaching infinite with same sign as ak by bm, like we have got on the very first case of the earlier possibility. Is it okay to all?
Yes, sir.
Yes, sir.
Just note down this portion quickly.
Sir, could you please scroll up a little?
To this section
Yes.
or any earlier section.
This one.
So let's get to the other subcase. Subcase B is when m minus k is odd natural number. So in that case, irrespective of bm, x to the power this odd value is not itself decided with its nature of approaching 0, and hence the behavior will stay inconsistent. So L2 does not have any fixed tendency in that case. Okay? If m minus k is odd, then as x approaching to 0, numerator will approach ak, and the numerically greatest term from denominator is bm x to the power the odd difference. But as x approaching to 0 plus, x to the power odd approaching 0 plus, whereas for x approaching 0 minus, x to the power odd will become 0 minus. So irrespective of the multiplier bm, itself this portion is not decided with how to approach 0. The behavior is not consistent. That is why when we will divide a non-zero numerator ak with some denominator which is approaching to 0, but the sign of the denominator is not fixed. So L2 may approach infinite, may approach minus infinite. This tendency cannot be fixed, and hence we will not be able to conclude anything about the limiting value L2.
So that
Okay.
is if we approach the 0 from negative side or the positive side, we would have a different limiting values for
We
each of
will
the
have
cases.
different limiting value, like just a while ago we have seen the graph of y is equals to 1 by x. The problem we
Yes,
had
sir.
around 0, it will be similar nature here.
Yeah.
Okay. So now bm cannot be the decider, and hence L2 L2 does not have any fixed tendency. The third case is again very special. If the least degree terms from both the polynomials of numerator and denominators are equal, then after the division, the numerator will approach ak and the denominator will approach bm. And only in this occasion, we are supposed to have a limiting value which is same as the ratio of the coefficients of least degree powers from the polynomials. And this is for the first time we have got a non-zero finite limit in this occasion. Is it clear? So basically both the parts are also comparable. In earlier part when x was approaching infinite, how we have decided on the basis of leading degree term and leading coefficient. Similarly, when x is approaching to 0, we have decided everything in terms of the least degree term from the polynomials and in terms of their coefficients. Is it okay with all?
Yes, sir.
Now let's decide over the indeterminate forms. What are the 7 indeterminate forms?
Sir, can you please show the case 3 once again?
Yeah, definitely better. Is it done?
Yes, sir.
So 7 indeterminate forms of limit means those 7 forms where we do have very strong individual parts and two such parts coming together trying to take the result in opposite way. So if we do have already, we do have already decided with two of the forms, right? So to write the indeterminate forms, we will consider very small numerical value will be denoted by zero. So while writing these forms, whenever we will write zero, it will not be considered as the constant zero, but we will try to mean something very small numerically. Okay? Next is very large numerical value that will be denoted by infinite. So though we know infinite is not a number but a denotation, so whenever we will try to represent large numerical values, we will be trying to represent that by writing infinite. So basically we are taking this denotation wise. Okay. And even if I write any constant, for the time being, believe that it is not the fixed value, but the approaching value of that been considered. Okay. So what are the 7 indeterminate forms? We will have a small numerator associated with a small denominator. Just a while ago, we have decided we will not stand conclusive over there. A large numerator associated with a large denominator. Is that okay?
Yes,
Yes,
sir.
sir.
Will
Yes, sir.
0 plus 0 be indeterminate?
No.
Two
Yes.
very small values been added. The result still supposed to be small.
Small.
Yes,
Okay.
sir.
Two very small values multiply. Will there be any difference?
No, sir.
No, sir.
A
No,
very
sir.
small value subtracted from another very small value.
No.
Still decisive.
Yes,
For
sir.
infinite, two very large values added.
Infinite.
Two very large values multiplied.
Infinite.
Infinite.
A very large value subtracted from another large value.
Not definite.
So not sure. Okay. Anything into 0, what is our general perception? Anything into 0?
0.
0.
Zero.
Anything into infinite?
Infinite.
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 If they come together, a very small value multiplied with a very large value,
Large value.
necessary?
Not decisive.
Not decisive.
Not necessary.
Can be very small also.
Yes, sir.
Can be something which is neither small nor large. Like simply go for this formation. 10 to the power 200. Large value.
Yes.
Yes, sir.
And
Yes, sir.
10 to the power minus 400. Small value.
Yes, sir.
Yes.
Yes, sir.
Multiply them. It will be small
Yes, sir.
because
Yes,
the
sir.
product will give you 10 to the power minus 200. Similarly,
Yes.
we can make the example result large or
Yes.
maybe something finite.
Yes.
So 0 into infinite and infinite minus infinite are the other 4 forms. Okay. So out of 7, 4 forms are this 4: 0 by 0, infinite by infinite, 0 into infinite, infinite minus infinite. Trying to convey you the message: small numerator by small denominator, large numerator by large denominator, a small value multiplied with a very large value, or a very large value subtracted from another very large value. Apart from this 4, if we believe 0 to the power 0, the power 0 will try to transform the exponent result into 1, whereas the base 0 will try to transform the exponent result into 0. So again, two very strong contenders working in opposite way. So that will be indeterminate. Almost due to similar reason, infinite to the power 0. Just this time, the base is trying to make the exponent result infinitely large, whereas the power still trying to make it 1. Apart from this 6, if your base approaching to 1, remember base is not constant 1. If base is constant 1, it doesn't matter what power you write, the result will remain 1. Okay? So if the base is something approaching to 1 and the power approaching to infinite. Now why this last form is indeterminate? Because we know that numbers which are higher than 1, if we keep on multiplying them with themselves, the value will increase. Whereas if you consider anything less than 1 and you keep on multiplying the number with itself, the value gradually decrease. So when your base is approaching to 1, not exactly 1, and the power is infinitely large, so in that case, we cannot decide whether it will be very large value or very small value because we do not know how the base is approaching to 1. Is that okay to all?
Yes,
Yes.
sir.
Yes, sir.
So these are 7 indeterminate forms. And how we are going to judge on them? Like you can identify why I have written them in 2 separate lines. The first variations, okay, the first line that has variations which are normal algebra among the variables. Excuse me. The first 2 forms are rational functions, variable by variable, polynomial by polynomial type variations. So rational forms, these are normal, multiplication or subtraction. But if you look into these variations over here, you do have exponent forms where base and power both involve variable. Until and unless you do have variables in a part, that cannot show you tendency of approaches, right? So when I'm saying the base is approaching 0 and power is approaching 0, that means both base and power will have variables, and such formations are not good to handle with, right? Like x to the power 4. What type of function it is? Algebraic, exponential, logarithmic,
Exponential.
trigonometric, কি বলবো?
Exponential.
আচ্ছা x to the power 4 যদি exponential হয় তাহলে 4 to the power x কি?
সেটা algebraic হবে না, x to the power 4 মৌলিক করলে।
This is algebra.
Yes.
Algebraic.
মৌলিক
When the
polynomial।
base variable and power constant, that's algebraic. And when the base is constant and power is variable, that is exponential. Right?
Yes, sir.
Yes,
What would I call x to the power x? Is it algebraic or exponential?
দুটোই।
দুটোই না neither?
Both.
Should we say both? Can a function be both?
neither।
Neither.
So না আমরা এটাকে algebraic বলতে পারবো না exponential? Algebraic এই জন্য বলতে পারবো না because the power is not constant. Exponential এই জন্য বলতে পারবো না because the base is not constant, right?
Yes.
So it's neither
sir.
algebraic nor exponential. So basically this is a composition. So we are not much comfortable on that. So as we are not comfortable over this variation, what is the easiest way to split it? What should I apply?
Log.
Log.
Log. The moment you apply log, now natural log of x to the power x, that is same as x into log x, right?
Yes,
Yes.
sir.
Is that okay to all?
Yes, sir.
So that means the last 3 variations which were not that good to be dealt with. If we apply log on that, so in that case, it will be 0 into ln 0, right? Eventually, which matches with 0 into minus infinite format of indeterminateness. Clear to all?
Yes, sir. Yes, sir.
Sir, why?
ln 0 is, or if you do have a logarithm whose base is very small but positive, gradually the logarithmic result approaching which value?
0 as the base is increasing. Sorry, as the
Is the base changing at all?
no,
Natural log.
no, it's greater than 1.
Is it okay with all?
স্যার
Yes,
বাট
sir.
এখানে একটা লগ এক্সট্রা অ্যাপ্লাই করছি তো সেটা লাইক সেটার উপর সেটা দিয়ে কোনো প্রবলেম হবে না?
হ্যাঁ, আমরা লগ এমনিতে ডাইরেক্টলি অ্যাপ্লাই করতে পারি না। যেমন ধরে নাও আমাকে কোথাও স্কোয়ার করতে হবে, তাহলে আমরা রুটের ভেতরে স্কোয়ার করতে পারি।
মানে
ধরে নাও আছে পি, আমাকে লিখতে হবে পি স্কোয়ার, তো আমি ব্যাপারটা এরকম রাখতে পারি।
না,
কনসিডারিং পি পজিটিভ।
আচ্ছা হ্যাঁ তাহলে রাখতে পারবো।
তাহলে যখন আমার লগ দরকার, শুধু লগ অ্যাপ্লাই করতে পারবো না, তাহলে আমরা এভাবে করতে পারি, e to the power log with respect to base e। এবার তুমি এখানে যে কোনো এক্সপ্রেশন লেখো x, বা যে কোনো এক্সপ্রেশন লেখো f of x, it is ultimately equivalent to f of x itself,
হ্যাঁ
right? So তার মানে শুধু লগ না, আমরা e এর পাওয়ারে ন্যাচারাল লগ অ্যাপ্লাই করতে পারি। সো এনিওয়ে, সেই e এর কোনো রোল থাকবে না লিমিটিং নেচারে, বাকিটা 0 ইন্টু লগ 0। লগ 0 কাকে অ্যাপ্রোচ করে? লগের কার্ভ মনে আছে? আচ্ছা,
Negative
ন্যাচারাল লগ
infinite.
মানে বেস মোর দ্যান 1, রাইট? তাহলে ইন্ডেক্স নাম্বার বাড়লে লগের ভ্যালুও বাড়বে।
হুম।
So we will have such a appearance for log. So যত আমরা আস্তে আস্তে ইন্ডেক্স নাম্বার 0 কাছাকাছি নিয়ে যাচ্ছি, লগের ভ্যালু কোন দিকে যাচ্ছে?
Negative infinite.
নেগেটিভ ইনফাইনাইট। Is it justifying now?
Yes, sir.
Ever
So
clear?
0 into infinite also represents 0 into minus infinite, right?
Yes. Just take the minus aside. Okay. এই ভেরিয়েশনটার উপরে যদি লগ নিই, so that's 0 into natural log of infinite, which is itself 0 into infinite variation of indeterminateness. এই ভেরিয়েশনটার উপরে যদি লগ নিই, তাহলে infinite into ln 1, and as you know, index number approaching to 1 means ln 1 approaching to 0. Clear? Is that clear to all?
ln1 approaching to 0 কেন?
আচ্ছা, log 1 এর ভ্যালু কি?
log 1, আচ্ছা হ্যাঁ 0।
That's always 0. Log continuous curve, তাহলে ইন্ডেক্স নাম্বার 1 কে অ্যাপ্রোচ করলে লগের রেজাল্ট 0 কে অ্যাপ্রোচ করবে।
হ্যাঁ স্যার।
ওকে, এই পর্যন্ত ক্লিয়ার?
হ্যাঁ স্যার।
স্যার কিন্তু এখানে যে
তার
আমরা
মানে
ই টু দি
যখনই ভেরিয়েবল টু দি পাওয়ার ভেরিয়েবল ভেরিয়েশন থাকবে আমরা লগ ইউজ করে আগে তাদেরকে রিডিউস করে নেব, and we have seen all the three variation more or less getting changed into this format of indeterminateness, right? Is that okay with all?
Yes, sir.
বাট আমরা একটা
Whereas-
ইনডিটারমিনেট ফর্মের উপর একটা লগারিদমিক অপারেশন ইউজ করছি, সো দ্যাট ডাজন্ট চেঞ্জ এনিথিং।
Yes, that changes, but you need to keep the balance like I have shown just a while ago. If it is just a log, then it is changing. If it is a to the power log, then it's not changing.
কিন্তু আমরা তো
So
এখানে ই টু দি পাওয়ার এটা লিখলাম না।
হ্যাঁ, ই এর পাওয়ারে যখন লিখবো ধরে নাও
হ্যাঁ,
is
so we will
something
write e to the power 0 into infinity
ধরে
by to
নাও
the power 0.
fx আর gx x এর দুটো এক্সপ্রেশন, so as x shows some approach or x shows some tendency, তার impact fx into gx এ যেভাবে পড়বে, if I write that in the power of 2, রেজাল্ট নিয়ে খুব বেশি কনফিউশন থাকবে
সো মানে fx into gx হোল স্কোয়ার্ড।
যে fx not fx into gx হোল স্কোয়ার, সেটা তো আমি পার্টিকুলার এক্সাম্পল দিচ্ছি। ধরে নাও
Sir, we will be able to identify the
limit
tendency, not the
x
exact value.
approaching to 0 x কিউব কাকে অ্যাপ্রোচ করে?
0
0 limit x approaching to 0 2 by x cube,
Infinity.
কিছু বলতে পারবো?
নো
ইনকনসিস্টেন্ট, তাই তো? কিন্তু লিমিট x approaching to 0 x cube into 2 by x cube কি হবে?
2.
2
2 এবার ধরে নাও লিমিট x approaching to 0 2 to the power x cube into 2 by x cube,
4
make it 5 to the power
25
25.
so বেসে 5 আসবার জন্য খুব বেশি অসুবিধা হলো?
No, sir.
But the limit still lies over here. 5 এর জন্য
Yes.
কিছু চেঞ্জ নেই, রাইট?
কিন্তু ওখানে তো লিমিটের ভ্যালুটা 2 আসছিল আর এখানে আমরা 25 পেলাম।
কোনটা বলো?
আগে যেটা একটাই 2 ছিল আর এটাই 25 পেলাম।
আচ্ছা, এবার ধরে নাও আমি তোমাকে বলছি আইডেন্টিটির দরকার পড়বে অ্যাকচুয়ালি। ধরে নাও এই যে দুটো কোয়ান্টিটি, এই যে কোয়ান্টিটিটা ছিল এটাতে ধরে নাও তুমি ই টু দি পাওয়ার লগ নিয়েছো, নাও
2
কোন রকমের অসুবিধা হবে?
নো
2 ই থাকবে তো?
Yes, sir.
That's what I was suggesting. তোমার লিমিটিং ভ্যালু যেটা সেটাই থাকবে, খালি আমরা লগটা ইন্ট্রোডিউস করে আমাদের ফরম্যাট গুলোকে রিডিউস করতে চাইছি। ক্লিয়ার?
ইয়েস
খুব বেশি ক্লিয়ার এক্ষুনি হবে না যতক্ষণ না আমরা প্রবলেমে যাব। So, একটু আমরা দেখে নিই। whereas এরা যে ফরম্যাটটায় রিডিউস হচ্ছে সেখানে আবার দেখো 0 into infinite, this is reducible to 0 by 0. আমি সঙ্গের ইনফাইনাইটটাকে এভাবে লিখতে পারি যে 0 ডিভাইডেড বাই রেসিপ্রোকাল টু ইনফাইনাইট, which is equivalent to 0 by 0 form.
Yes,
Right?
sir.
তার মানে ইভেন্চুয়ালি এরা 0 by 0 ফরম্যাটে রিডিউস হয়ে যায়। ক্লিয়ার? যেটুকু পোর্শনে লিমিট ইনভলভ সেই পোর্শনটুকু অ্যাট লিস্ট।
Yes.
Okay,
Yes.
is that clear? Next, write down the algebra of limit.
So তাহলে ইনফাইনাইট বাই ইনফাইনাইটটাকে আমরা নিচে ডিনোমিনেটরে নিয়ে গিয়ে ওটাও তো 0 by 0 করতে হবে।
ওটাকেও 0 by 0 তে চেঞ্জ করতে পারি, বাট ওটার জন্য আমরা আলাদা করে আর লিখলাম না, বিকজ অলরেডি ইট ইজ আউটসাইড দি লুপ। These three were getting changed primarily into 0 into infinite, which is reducible to 0 by 0. Okay? Infinite by infinite যদি দরকার পড়ে তার জন্য অলরেডি আমরা একটু আগে L1 ডিসাইড করে রেখেছি, so you know how to handle that.
Yes.
Okay, so next is algebra of limits. Very simple algebra. It says limit is commutative with constant multiplication. So firstly you multiply a constant, then take limiting value. It is same as firstly you take the limiting value and then multiply the constant. Second point says limit is distributive over all basic algebras. Provided the distributed limits are existed. What does that mean? That if I do have f of x plus or minus g of x, you take a limit on that, it will be indivisible limit of fx plus or minus indivisible limit of gx. The same thing will happen if it is a product. But while doing this, all we need to be sure of that when we are distributing, the part limits should be existent. Like just a while ago, we have seen limit x approaching to 0, x cube is existing, but limit x approaching to 0, 2 by x cube is not existing, but their product was existing. So if you do have limit x approaching to 0, x cube into 2 by x cube, that cannot be written as limit x approaching to 0 x cube multiplied with limit x approaching to 0 2 by x cube. And why this cannot be done, that's been mentioned over here. Is that okay to all?
Yes, sir.
Yes.
And the last point is, if you do have a ratio and you need to address limit for that, you can go for limit of the numerator by limit of the denominator. Again, we can only do that when it is well understood that even after distribution, the individual limits are existent. So far, is that clear?
Yes, sir.
Okay, so
Yes, sir.
for today's session, we'll be keeping our discussion limited to this far only. In our second session, we will extend it to the identities of limit and how it can be dragged into the derivative part. Okay, the procedures of limit and how it can be dragged into derivative. Okay.
Okay.
Yes.
Okay, sir.
Yes.